You ever look at two math problems that seem almost identical, but one has just a single answer, while the other has, well, an infinite number of them? It's not some kind of trick. It's actually a really cool hidden symmetry. And today, we're going to crack the code and find the one simple rule that connects and separates them both. Okay, just look at this. On the left, you've got x plus 5 equals 12. Super straightforward. There's only one number in the universe that can make that statement true. But then look at its sibling on the right. X plus 5 is greater than 12. Suddenly, there's a whole family of answers. So how does one tiny symbol completely change the game? Well, the answer lies in one shared principle. Here's the key to solving both of these. You have to think of them as a balancing act. You know, like one of those old school scales. There is one fundamental rule that governs this whole family of problems. And honestly, it's the only thing you really need to burn into your brain. And this is it. This is the golden rule of algebra. It's what keeps everything in perfect harmony. It doesn't matter if you're adding, subtracting, multiplying, whatever, you have to keep that perfect balance. This is the absolute heart of everything we're about to do. So how do we actually use this balancing rule to figure out what x is? We use these special tools called inverse operations. The easiest way to think about them is like the undo button in math. They're how we carefully take things off of our scale, piece by piece, without tipping it over, until we get that x all by itself. And the cool thing is how simple these pairs are. Addition and subtraction, they're opposites. They just cancel each other out. Same thing goes for multiplication and division. These are literally the only tools you'll need to keep that scale balanced and find the answer. All right, enough talk. Let's actually put this into practice. We're going to start with the more straightforward sibling, the equation. This is where we're on the hunt for that one single solitary answer. Okay, let's take a look at 3x equals 12. Our goal is to get x all by itself. So we've got to undo that times 3. And what's the inverse of multiplication? Division, right? So we apply our golden rule. We divide both sides by 3 to keep the scale balanced. On the left, the 3's cancel out. And on the right, 12 divided by 3 is 4. And boom, there it is. X equals 4. Balance maintained. Puzzle solved. And that's really the beauty of equations. It's just a clean, predictable process. You follow the rules of balance and you land on one single correct answer. But what about its more complicated sibling? Let's move on to inequalities. Now, they look almost the same. And guess what? They follow almost all of the same rules. It's still a balancing act, but instead of finding one single point of balance, now we're finding a whole range of possibilities. Before we start solving, we just need to get the language down. These signs tell us about the kind of answers we're looking for. Greater than and less than use an open circle when you graph them, which just means the number itself isn't included in the answer. But greater than or equal to and less than or equal to, those use a closed solid circle because that number is totally part of the solution. So since they look so similar and they use the exact same balancing act with inverse operations, you would think the process is identical, right? Well, almost, but there's a twist. This is it. This is where the inequality sibling shows its unique personality. There is one special case, one little secret rule that only applies to inequalities, and you absolutely have to know it because it changes everything. And here it is, the one big secret, the flip rule. Anytime you multiply or divide both sides of an inequality by a negative number, you have to physically flip the direction of the inequality sign. Why? Because multiplying by a negative actually flips a number's position to the opposite side of the number line. What was greater than becomes less than. This is the one and only twist you need to remember. Let's watch this rule in action. To solve negative 2x is greater than 8, we have to divide by negative 2. The second you decide to do that, alarm bells should be going off in your head. The flip rule kicks in. We do the math, which gives us x and negative 4, but we must flip the sign from greater than to less than. So our answer isn't that x is greater than negative 4, it's that x is less than negative 4. That is a completely different set of answers, all because of that one little flip. Okay, so now you know the golden rule and you know the special flip rule. To really get this down, let's just quickly go over the most common places people get tripped up. If you could avoid these, you are golden. So here are the top 3 things to watch out for. Number 1, and this is by far the most common, forgetting to flip that sign when you multiply or divide by a negative. Number 2, just forgetting the golden rule and doing something to one side but not the other. And finally, when you're graphing, mixing up those open and closed circles. The easy trick? If the symbol has that little extra line for or equal to, then your circle gets filled in too. So,
The next time you see an equation and an inequality next to each other, don't get thrown off. Just remember they're family. They both live by that same rule of balance. It's just that one has a single, dramatic little twist you have to watch out for.
And there you have it. Two problems that looked almost the same, but they're governed by this beautiful, symmetrical logic that just has one tiny exception. You didn't just learn a math rule today, you learned how to look for the hidden connections in things. So the real question is, what's the next puzzle you're going to solve?